Welcome to the deep dive.
Glad to be here.
So today we're getting into how AI models actually make sense of information, or try to.
Yeah, we've got to look at some tests run on two different models. Let's just call them A and B. We're
Hmm.
seeing how they categorize things.
Right. And the goal for you listening in is to kind of understand the challenges here. Why does AI sometimes nail it and other times, well, completely miss the mark?
Exactly. We saw a few kinds of results in these tests. Sometimes perfect recognition, spot on.
Okay.
Other times it gave an undefined label. That could mean the sample was maybe sort of similar to something it knew, but the confidence was low,
Whoa.
or it was just way off base, totally unrelated, maybe even problematic data.
It's pretty fascinating how seemingly simple tasks can reveal these really surprising complexities in how AI works.
It really is. So let's jump into the first example. This one was, well, a clear win.
Okay, could start.
Both Model A and Model B were shown in orange. Simple enough, right?
Seems like it.
And they both nailed it. Really high confidence. Model A was like 99.8%, Model B 98.1%.
Wow. Okay.
And interestingly, they had slightly different training data behind them, but still, both got it right. Shows some robustness sometimes.
So even with like minor variations in their education, they both clearly understood orange. That's good, but I have a feeling it gets trickier.
Yeah. That brings us to the second case. We called it the low confidence conundrum.
Conundrum, I like it. What happened?
Here, the sample image, it just didn't quite fit the patterns the models had learned. So both models were pretty unsure. Low confidence scores all around.
Okay, so both hesitated, but was there a difference?
Big difference. Model A, which actually had fewer categories in its training, it still guessed orange.
Ah.
It did this across like 9 different variations of this weird sample, but always with low confidence. It was basically saying, maybe orange. Not sure.
Okay, consistent but uncertain. What about Model B, the one with more training data?
Model B, perhaps because it knew more things, it actually guessed wrong and said sliced bread.
Sliced bread. For something related to an orange.
Yeah, apparently there was some visual similarity that tripped it up. But again, also with low confidence.
So one consistently guessed the right category uncertainly, the other guessed the wrong category uncertainly. How did the experts see that?
Well, the expert review felt Model A's consistent, even if hesitant, guess for orange was actually, more reliable in that situation.
Interesting. More reliable even though it wasn't sure.
Exactly. Compared to Model B confidently picking the wrong thing, sliced bread,
Yeah.
it really shows how the scope of the training data matters. Fewer options might make a model stick closer to home, even if uncertain.
Whereas more options might lead it down a weird path based on just a visual cue.
Got it.
Got it. Okay, scenario 3.
Scenario 3, the noisy intruder.
Sounds ominous.
Well, it was basically a messy sample. Imagine asking for orange and getting back a color chart, with lots of different shades of orange on it.
Ah, okay. Not an actual orange fruit.
Precisely. And this noisy sample, it confused both models. Across all those 9 variations again, they consistently gave low or inconsistent confidence scores.
And the label.
Undefined label, straight across the board.
So they both recognized this wasn't what they expected for orange.
Right. The expert review confirmed that undefined label was the correct assessment. It shows they're sensitive to, well, irrelevant stuff that doesn't fit the core concept.
Okay, that makes sense. What about the next one, the sneaky mislabeled item?
This one's a good one. The sample was labeled orange, but the picture, it was actually orange-colored Nike shoes.
Oh, okay. So the text label says one thing, the image is something else entirely.
You got it. And what happened?
Yeah.
Neither model could identify it based on the orange concept they knew.
So, undefined label again.
Yep, both models threw up their hands, essentially. Undefined label.
It really highlights how much they depend on the visual training, not just the text label, doesn't it?
Absolutely.
Yeah.
If the label's wrong and the image doesn't match the visual patterns for that label, the AI is kind of stuck. It's a big reminder about data quality, both images and labels, super important.
Makes sense. Okay, one last case. The labeling labyrinth.
Ah, yes, the labyrinth. This is all about inconsistent training data. Imagine feeding the AI the same picture, but sometimes you call it a car and other times you call it a vehicle.
Oh, that sounds like a recipe for confusion.
It is. So Model A, which hadn't actually been trained on either car or vehicle specifically like this, it correctly just said undefined label. It didn't know what to make of it.
Okay, ignorance is bliss, maybe.
Sort of. But Model B had been trained with this messy, inconsistent data, and its predictions were all over the place. scattered guesses
Before doing what?
before it too ultimately landed on undefined label.
So even the model that had seen related things got confused because the labels were inconsistent.
That's the key takeaway. That poor data quality, the inconsistent labeling, it really hindered Model B. Even if it was potentially a more complex model, the bad data just messed it up.
Wow. So wrapping this up, it seems like the really crucial thing is figuring out when there's a mismatch between what the AI learned and what it's actually seeing in a test.
Exactly. And realizing there's a difference between an AI saying, I think it might be this, but I'm not sure, versus I have absolutely no idea what this is. One is uncertainty within its knowledge. The other is completely outside it.
Right. The known unknown versus the unknown unknown almost.
Yeah, something like that. And it makes you think, how much do these AI struggles kind of mirror our own human learning?
How so?
Well, think about how important clear definitions and consistent information are for us when we learn something new.
That's true. Ambiguity makes things tough.
Definitely. So the thought to maybe leave folks with is, what kinds of noisy or like mislabeled information do we run into every day? In the news, online, conversations, how do we filter it? How do we decide what's reliable?
That's a really interesting parallel, how our own brains handle messy data versus how these models do. Lots to chew on there.
For sure.
All right, that's our deep dive for today. Thanks for breaking that down.
My pleasure.
And thank you for joining us. We'll catch you next time on The Deep Dive.